Hello, teacher. Today I will be presenting my analysis of Netflix movies and TV shows dataset. Over the next 10 minutes, I will share insights drawn from the data, highlight new elements added during analysis, and briefly walk you through the dashboard I built to visualize key trends. Uh, the goal of this analysis was to explore content trends, identify significant factors affecting content creation, and use data-driven methods to predict future trends. And this article is meant to solve these four problems, like what is the distribution of Netflix content based on country, and how does it compare to global media production trends. Uh, and the second one is what is the significance of year of release, average length, and number of actors on content creation. The third one is how has the trend in duration of content changed over the years, and what might be the financial and environmental implementation of this trend. And the last one is how can regression models be used to predict future content cost numbers and the related production trends. Mm, about my data preparation and cleaning, I do this main four methods. The first one is remove invalid and blank data. This is the original data. This is my data after cleaning. I use filters to remove invalid and blank data, and split and trim the field like duration, and use the power power pivot to manage my data um, like this, and use Power Query and Power Pivot for data relationships. I make the relationship view like this, and then creates the private table, private table like this one. The dataset includes 8,000 titles with details such as type, genre, director, country, race, year, rating, and duration. Significant cleaning and transformation were performed. I delete nearly 1,000 data here. Mm, and then I will briefly show my data analysis. First, I compare this dataset with the too many datasets like IMDb and TMDb, and this will show a sample of difference here. And then I do the analysis of my dataset. I draw many graphs here, and I will show you in dashboard. I make a detailed dashboard here. It will separate the two types like movies and the TV show. Uh, this is a slicer. We can click here to change the dashboard. One is movie and one is TV show. Sorry, and the data here will change the while I click the button. Mm, the dashboard showed that the first one is the top 10 production countries about movies and TV shows. The United States leads with 2,074 movies, followed by India, showing the dominance of these two countries in global content production. About TV shows, Japan stands out with 197 TV shows, mainly due to its strong performance in animation. Mm, and the second one is the genre distribution. International movies is most one. It's most types of films, and in TV shows, international TV shows also shows the lead. About um, release date trends, steady growth in movie release since 2017, with peaks in November, likely linked to holiday seasons, and the TV shows also see consistent growth, but at slower rate than movies. Netflix seasonal content release strangely aligns with consumer behavior patterns. About the ratings distribution, R-rated movies dominated, appealing to mature audience, and family-friendly ratings about TV dominant, um, while TV 14 targets teens and young adults. Netflix effectively tailors to tailors content for device audience segments from families to adults. About duration and life, mm, Netflix balances content duration to align with consumer habits and engagement needs. About actor count by year, mm, this rising actor content reflects Netflix investment in high quality, intricate productions. And the last one is actors count by rating, like this paragraph. Well, this graph. This cut size align with target audience needs and production complexity for different ratings. Okay, and then I'll show the new column I added is the count of cards. I use one function to com to compute it. If and the minus the length of subtitle. This cell, and we'll get the content of the cards here. Okay, I do the descriptive analysis here. And this will draw the conclusion that sorry. This draw a conclusion that the data distribution of TV shows show a sharp peak and a large scaleness, which implies that there may be outliers in number of actors for TV show. And in contrast, films has a lower courses and scaleness, indicating a more concentrated and symmetrical distribution of numbers of actors of films. And then I do the regression analysis here. You use the data analysis and create a sheet like this. This will draw the conclusion that regression models show that release year, duration, and cut size significantly impact content creation. And at last, I do the collaborative filtering by learn by myself and use this model. Use Python code to do this, and collaborative filtering is a recommendation system technique that predicts user preference based on past behavior and similar user patterns. In this project, I use collaborative filtering to recommend movies similar to the selected title, like Bloodwater, and compute the similarity score and get the five movies is most connected to this movie. And the steps like conclude data preparation, TF-IDF transformation, similarity calculation, and get the results. And at last, I answer these 4 questions that I asked before and draw conclusion here. I briefly introduce it. The US and India leads in production, while Japan excels in TV animation. International genres dominate Netflix strategy, and regression and collaborative filtering enhance future prediction and recommendation. Thank you very much. And this is my reference here, like 2 articles and the Python code.